Kia ora whanau. This video is about an additional aspect of the normal distribution, and it's about how to use this formula that's on the screen there. Let's get started. So what are we dealing with here? Well, what we are used to dealing with in a straightforward normal distribution problem is you are given some information. So if we look at the blue shaded area there, we might be asked to find that probability there with those specific parameters. The mean of 1.8, standard deviation of 0.18, and our value of 2 there, 2.0 meters. So as you can see, it's the probability between 1.8 meters and 2 meters. Equivalently, on the right hand side of the screen there, we could draw a standard normal distribution with a mean of 0 and a standard deviation of 1. But in order to calculate the probability that we want using a standard normal distributions table, we would need to find the value of that question mark and then use our standard normal distribution table to find the probability. That is the shaded area either in the blue or the orange. If you're using a device or a calculator of some sort, then we will just need to plug in the value straight away from the blue distribution. But anyway, let's have a look at what we're dealing with here. So the normal distribution is denoted by x, so that 2.0 meters, we're going to call that the x value, and the question mark we're going to call the z value, which is related to the standard normal distribution. So that formula we saw before is used to find the z value, and you may wish to consult one of the previous episodes to get your head around this if it's not familiar to you. Alright, so in words, that formula there is the mathematical relationship between the normal distribution, which is on the left hand side, and the standard normal distribution, which is on the right hand side. As I said, this should all be familiar to you, so please take your time to go back and maybe look over this again before you proceed. We're going to cover two cases, so let's get started straight away. Case number 1. We're concerned with finding the mean. So let's say we're given a question and this is the information that is fleshed out of the question. So you've got a standard deviation of 9.8. The mean, we don't know what it is because obviously we're trying to find it or calculate it, but we're given another piece of information. The probability that x greater than 124 is 1/3. Okay, so what we should do is, let's see what it looks like visually. Okay, so we know we're dealing with a relationship between the normal distribution, or the x distribution, and the standard normal distribution, or the z distribution. So in terms of the information that I've got there, I've put it in blue for you, right there, and this is what we're dealing with. And I've got a little question mark by the mean, because that's what we're looking for. So what do we do next? Well, into the formula. There's our little relationship there. We need to do a little bit of algebraic manipulation. It's not complicated algebra, but nonetheless, please try and follow along. So, what I've done first is multiply both sides of the equation by the standard deviation. The two on the right hand side of the equals cancel out. So I'm left with this guy here. Standard deviation of times z equals x minus m. The next thing I need to do, let me rewrite this with some spaces. These last two steps are the same or equivalent. What I want to do first is subtract the standard deviation times z from both sides. Then I want to add the mean to both sides. And the reason I want to do this is these two cancel out or become 0, and then these two cancel out and become 0. So what am I left with? I'm left with the mean equals x minus standard deviation times z. There you go. If you remember that formula, you're going to be good to go to find the mean. So, in terms of the solution, before we get to that, obviously we're dealing with the z distribution, so let me plug in the information that I know. There we go. That's the information that I know from the standard normal distribution, mean of 0 and standard deviation of 1, and my probability is 1/3. What I need to do at this point is to find the z value is use the inverse normal method, which I also cover in a previous video, to find the Z value. 0.4307. At this point, if you don't know what the inverse normal or how that works is, then I suggest you go back to the previous video about using inverse normal, or using normal distribution backwards to find the value. Anyway, let's carry on. So the solution is here. There's my formula that I've just found. Sorry about that. There's my formula that I just found. And there's the x value, 124. I'm going to subtract the standard deviation times my z value. And I'm left with 119.78. And that's my mean. If you wish to check your answer, you can plug in the value of the mean and the standard deviation of 9.8 and use whatever method you need to find that, to confirm that we get 1/3. So that's finding the mean. So one more case we need to consider is finding the standard deviation. So there's our setup again. I'm going to use some different information this time. So say we're given a question, we're asked to find the standard deviation, we're given a mean of 72, and we're told that the probability that x is less than 70 is 0.091. So let's see what that looks like. And there's all our information there. Obviously I've got a question mark by the standard deviation because that's what I'm looking for. So in terms of what we do next, let's go to our formula there. Now the next step is swap these two things around. And once you've done that, you got your formula. You may wish to remember that or understand how to get there, but however you want to do it, that's absolutely fine. So in terms of the standard normal distribution, there's my information. Mean of 0, standard deviation of 1, and we need to use inverse normal methods to find the z value. And we're going to get negative 1.333 recurring. I've just used negative 1.33 there. Now the negative is particularly important in this case, so you should use the negative when we're performing our calculations. So for the solution, there's a formula there that we've just found. Numerator 70 minus 72, x is 70. We're going to take away the mean of 72. And we're going to divide by our z value, which we've just found. Remember to keep the negative in there. And if we've entered that correctly on our calculator, we should get a standard deviation of 1.5. Great, that's it. We will see you next time.